about ellipse, one of the conic sections. Ellipse is a shape we got when we cut a cone in a slant manner like this. So it's going to give us ellipse at the surface. As I told you, so many researches have been done, so many studies have been done on ellipse, and that is what is helping us to achieve results today. Another thing I like to tell you is this: when ellipse will be drawn, that's how we draw it. We use thread, tight thread, and pen. This one represents the pen here, and we join the thread to the different focus. We now trace the pen round, making sure that the thread is taut, and then it will give us the shape we are looking for, which is ellipse. So invariably, the distance of any point from, when you add the distances from P to F1 and P to F2, when you add the two of them, it's going to give you the total length of this thread, which is 2A. You will get it. You know what A is now? The vertex of the ellipse. So that's the major introduction to this shape. It is very useful, and we will derive certain equation for the ellipse now. Now, while we are still working on this, please, I'd like to remind you to share, to like, to comment, and to subscribe. We have talked about eccentricity before. Eccentricity is the ratio of the distance from a point on the curve to the focus to the distance from the directrix. We have talked about directrix before in a parabola. Is the vertical, is the perpendicular axis to the transverse axis of the conic section. Now, let's get some points out. This is one vertex, the second vertex. I want to get the relationship between A, C, and D. Now, F1, the distance of F1, A from F1 to the distance of A from D is E from our explanation. Please, this distance is perpendicular distance. The distance we are referring to here is perpendicular distance from the directrix. Okay, so we have this point is a vertex, so V. So we can say A, the distance of A, A from here is A from C, F from here is C, D from here is D. This is the directrix, please. Now, so the distance of F from A is A minus C. So let's see. F V. Let's call this place V. F1V over VD is equal to E. And E, yes, please. E in this instance is always less than 1. E is less than 1 and greater than 0. Please take note of this. It's very, very important. This determines this shape. This determines this shape. If E is greater than 1, it is something else. It is giving us a different shape. And you know from the last one we talked about, if E is equal to 1, it's giving us parabola. If E is greater than 1, it is giving us hyperbola. Please. Now, and this is A minus C over D minus A. Fine. Now let's look at another thing. This place from F1 and this place from D there is also E. Let's call this place V2. V2. So F1 V2 over V2D is equal to E. So what does that give us? So what is the distance of V2 to F here? You know, this is minus A. This is the center. So we have C plus A over the distance from here to here is also D plus A is equal to E. Please, we are trying to bring out a very important result. So we have A minus C is equal to ED minus EA. A plus C is equal to ED plus EA. Look at a very funny equation. So this is 1, this is 2. Now, if we add 1 and 2, we are going to have 2AA. If we add this one 2, we are going to have 2ED. So what do we have here now? Which means that D is equal to A over E. D equals A over E. Now, let's subtract the first equation from the second one. We have 2C and is equal to 2EA. So, what's the relationship between C and A now? C is equal to AE. Please note, C equals AE. These are very important results. Now, we're also trying to get another result. We're also trying to get another result. Now, what's the relationship between B and A at the same time? B is the co-axis, co-vertex, sorry. The ratio of the distance of B from C and distance of B from D is also E. So let's work on that. What is the distance of B from C? So we have 0 minus C squared plus B minus 0 squared is equal to E. What is the distance of this place from this place? Please note, this point, the distance, the height here will be B, and it will be DB. Please note, because it is perpendicular. So E into D minus 0. Look at this. And B, you can see, is the same thing. So it's going to be ED. ED. And we know what D is. D is A over E. So E times A over E. So we have, so let's square the equation all through. So 0 minus c is minus c. So minus c squared is equal to c squared. B minus 0 is b. So we have b squared. So this one is going to give us a squared. So invariably, b squared equals to a squared minus c squared. What does that tell us? It tells us that the distance of b from F1 is A. This place is A. This place is C. Can you see? So at the end of the day, we can still break it further. So we have b squared equals a squared minus c squared. We know the relationship between c and a. C is ae. So which is equal to a squared minus a. So b squared is equal to a squared minus a squared e squared, which is equal to a squared into 1 minus e squared. This is another important result. So we have these 4 equations now. 1 minus e squared. Very important equations. Now to get the equation of ellipse, let's pick a point here. This point is P. Let's call it P. Let's call the point P here. And we have it x, y. That's the coordinate of this point. X, y. So this is the distance, and this is the distance of the directions. Thank you. So we have it. The ratio of P F1 and P to PD is E. So we have P F1 over PD. That is the distance from this place is equal to E. Now what's the distance from P to F1? That will give us x minus c, and we know what c is from this place. Let's change it to ae straight, and let's change this one to a over e so that we don't waste time. So we have x minus ae. Now to derive the equation, we know the distance, so we can say pf1 over PD, that is perpendicular distance, is equal to E. Now let's work it out. X minus AE squared plus Y minus 0 squared is equal to E into D. That is AE minus x. So let's square both sides. We have x minus AE squared plus y squared is equal to, oh, this one is A over E. A over E, sorry. A over E. So it's equal to E A minus EX all squared. Please take note of that. That's A over E, because that's D. Now, let's subtract x minus A E all squared from both sides. We have y squared equals to A minus EX squared minus x minus AE squared. So let's use difference of two squares. It's going to give me A minus AE minus EX plus X into A plus AE minus EX minus X. So let's factorize. That will give me a into 1 minus e plus x into 1 minus e. This one will give me a into 1 plus e minus x into 1 plus e. So the result is this. Factorizing everything is going to give me a plus x into 1 minus e, a minus x into 1 plus e. So you can see 1 minus e times 1 plus e. What does that give me? It gives me 1 minus e squared. A plus x times a minus x. That gives me a squared minus x squared. So you can see. Let's divide through by 1 minus e squared. So I have y squared over 1 minus e squared is equal to a squared minus x squared. Is equal to a squared minus x squared. Then I can add x squared to both sides. So I can have it like this. X squared plus y over 1 minus e squared is equal to a squared. A squared. So let me divide through by a squared. So I have x squared over a squared plus this y squared plus y squared over a squared into 1 minus e squared is equal to 1. And remember from our results, b squared equals to a squared into 1 minus e squared. So finally, the equation is x squared over a squared plus y squared over b squared is equal to 1. So that is the result for the equation of an ellipse. Now let's look at a situation. Here the center is moved to HK. Yeah. You know, from a parabola, we just know that we just replace the y by y plus k, y minus k rather, and the x by x minus k in the equation. But here, I prove it for you. What will happen to other positions? This one too will become h plus ae, and this place will become k. You know, it's a plane. Every other thing moves. Just like if I move now, every part of my body will move at the same time. So it's just like we move it and we place the center to position HK. So what happens now? This place will be, instead of 0, this place will be H. And what happens to this place too? It will be B plus K. What happens here? It will be H plus A. H plus A. And this place will be K. This place will be H plus AE. And this place will be K. So please, I want us to get it very well. This place will be K minus B. This place will be H minus A. This place will be K. This place too will be H minus AE. Since we know that C is AE. And this place will be K. Please, I want you to know this. When the center is HK, that is, you have moved it to a different place. This place too will change. It will be H minus A over E and K. Please, I want you to study the diagram very well. Now, the formula still remains as it was. for the distance. Now let's do justice to this. F1p all over PD is equal to E. What is F1p? You are going to have yx minus h plus ae all squared plus y minus k squared. Let's square root it. It's going to be e. This place has become h plus ae minus x. So we have h plus a over e, sorry please, minus x. So that's what we have here. So which will be eh plus a minus x. Please, I want you to take note of how I'm writing out this thing. I'm writing it out for ease in getting out the figures. Now, let's square both sides. We have, oh, this one should be ex. This one should be ex, please. Yeah, minus ex. Now, let's square both sides. I have x minus h plus ae all squared plus y minus k all squared is equal to eh plus a minus ex all squared. Now let's subtract this one from both sides, just like we did the other time. So we are going to have y minus k squared is giving us eh plus a minus ex squared minus x minus h plus ae all squared. Now, y minus k equals to eh plus a minus ex squared minus x minus h plus ae squared all bracket squared, as you can see. So using difference in square, a squared minus b squared equals a plus b into a minus b. So that's what I did here. So I added and then I subtracted. So I have eh plus a, this one, minus h minus ae here, minus ex plus x here, that is the sum. Eh plus a plus h plus ae, that is the difference. You know, this minus will turn to positive. Minus ex minus x. So everything I now rearrange to the group. So I brought this one a minus ae plus x minus ex plus minus h plus eh. You can see. So for this one too, a plus ae minus x minus ex plus h plus eh. Please, I want you to follow that. So this one, a into 1 minus e plus x into 1 minus e minus h into 1 minus e. That one comes here. A into 1 plus e minus x into 1 plus e plus h into 1 plus e, all brackets. So I want that one to be clear. With this, we have gotten our answer. Now, I now factorize again. So I have y minus k squared is equal to 1 minus e, this one is common to all of them. 1 plus e is common to all of these ones. So what is left here is a plus x minus h. And I have here too a minus x minus h. Please, when I put minus here, this positive here will turn to minus. So at the end of the day, I have 1 minus e squared bracket into a squared plus x minus h bracket squared all squared to multiply this. Now I can divide through by 1 minus e squared. So I have y minus k squared over 1 minus is equal to a squared plus x minus h squared. Straightforward. Now, no, this one is minus this. A squared minus x minus h squared. Minus please. Sorry about that. Thank you for following. Now please remember to subscribe and share and make comments. Now let me add x minus h squared to both sides. So I have x minus h squared plus y minus k squared over 1 minus e squared is equal to a squared. Divide through by a squared. I have x minus h all squared over a squared plus y minus k all squared over a into 1 minus e squared. A squared over is equal to 1. Can you see the semblance now? Can you see the semblance to the other one we got? So a squared into 1 minus e squared is b squared. So we have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. That is the result. So when we shift it, is the center we consider now. Please. For parabola, the vertex was the origin, 0, 0. So when we are considering the movements, what we take note with to make the solving of any problem easy, you look at it. For parabola, it is the vertex that is changing. For ellipse, it is the center. Just try to go and consider what the center will be like, and then you'll be able to solve your problems. So we have gotten two equations now. We have gotten this one where the center is hk, and we have gotten this one too. When the center is 0, 0. Now to get the tangents. It's easy to get the tangent. All you do is to use your knowledge of calculus. So if you are given a point or whatever, but sometimes it may be an exercise in algebraic form. Now let's go. To get equation of tangent at point x1, y1, all you need to do is this. Differentiate these ones and then you get it. So you have 2x over a squared plus 2y over b squared dy dx, which is equal to 0. So our n gradient is dy dx equals minus 2x over a squared times b squared over 2y. So we call this. So we have minus b squared x over a squared y. Please don't forget this minus. It's key. Now at the point x1, y1, n is equal to minus b squared x1 over a squared y1. We have already been given the points. The next thing to this, y minus y1 over x minus x1 is equal to minus b squared x1 over a squared y1. So we have a squared y1 minus a squared y1 squared is equal to minus b squared x1 minus x1 squared. I think it's better I also factorize this one like this one. So we have a squared y1 minus y1 squared is equal to b squared into x1 minus x1 squared. Yes, this is minus. So this one will give me, because of this minus sign, I'm going to have b squared into x1 squared minus x1. Please, I hope you are following. This minus here will make me to interchange this. Now, let me divide 2 by a squared b squared. Divide by a squared b squared. So I'm going to have y1 over b squared minus y1 squared over b squared is equal to x1 squared over a squared minus x1 over a squared. So let me add y1 squared over b squared to both sides and x1 over a squared to both sides. So I'm going to have x1 over a squared plus y1 over b squared is equal to x1 squared over a squared plus y1 squared over b squared. And from our initial equation, the two of them, they satisfy this equation. So x1 squared over y1 squared, sorry please, this is y1 squared, I don't know why, is equal to 1. Please note that. So for the tangent equation, we are going to have x1 over a squared plus y1 over b squared is equal to 1. That's the equation of the tangents. We have to prove it. But you know, if you are given the equation straight and just ask you to find this thing, you don't need to go through all this. This is where the work is. The answer you get here, you just substitute here straight and you get your answer. Now, if it is normal, all you need to do is to substitute the n by minus 1 over n. If it's normal, it's going to give us the gradient of the normal is going to be minus 1 over n, which should be a squared y1 over b squared x1. That is the gradient of the normal. Let me just make it like that. Gradient of the normal. So, what do you do when you want to find the equation? You just say y minus y1 over x minus x1 is equal to g. And that is your g. So you substitute and you get your answer straight. Now let's quickly look at the other one. If the equation is x minus h squared and y. Now, if you have equation in this form, and you have to prove for the equation of tangents, let's look at what we do. We use our normal calculus to find this one too. So it is going to be 2 into x minus h. Or the differentiation of this times 1 over a squared plus 2 into y minus k times 1 over b squared dy dx is equal to 0. So I have 2 into y minus k over b squared dy dx is equal to minus 2 into x minus h over a squared. So n, that is dy dx, is going to be minus 2 into x minus h over a squared times b squared over 2 into y minus k. So what does that give me? Yeah. So n is equal to minus b squared over a squared into x minus h over y minus k. So at the points x1, y1, our n, the value for our n will be minus b squared over a squared into x1 minus h over y1 minus k. There are still so many kind of equations under the conic section, but when we are doing solving questions, solutions, under that place we'll do some other ones. Now everything is very easy, please just follow. We now have y minus y1 over x minus x1 minus b squared over a squared into x1 minus h over y1 minus k. Then we can now say, this one is a bit long, a squared into y1 minus k into y minus y1 is going to give us b squared into x1 minus x. Please note this, because of the negative I interchange this into x1 minus h, x1 minus h. Please note that. So I have, so on expanding, I have a squared yet here into y1y minus y1 squared minus ky plus ky1 is equal to b squared into x1 squared minus x1h minus x1 plus xh. Please, I want you to follow that. Now, look at this. This is a squared into y1 minus ky minus y1 squared plus ky1 is equal to b squared into x1 squared minus x1h minus xx1 plus xh. So I'm trying to complete the square in this instance. So I have a squared into y1y minus ky minus y1 squared. You know this one is not complete. Plus ky1. I added ky1 and subtracted ky1 again to complete the square, please. And I added k squared and subtracted k squared again. The same thing I did here. B squared into x1 squared minus x1h minus x1h plus x1h, so that I'll be able to complete this. So minus xx1 plus xh. This one is not yet complete. I am supposed to add h squared and subtract h squared at the same time. Hope you are following. Now the next thing for me to do is this. I have a squared into y1y minus ky plus ky1 minus plus k squared. Now I've completed the square in this place. So I have squared, I have explained this one, into y1 y minus ky minus ky1 plus k squared, the last one here, minus y1 squared plus 2ky1 minus k squared here. So I have rearranged the equation there. I also have b squared here, x1 squared plus 2x1h minus 2x1h. You know this one is still pending. I threw it at the back. Plus h squared. I brought this one here. So I have minus x. I have this x1h minus xx1 plus xh minus the remaining h squared here. Please look at it very well. Then I factorized. It's a squared. I have gotten this one here. So a squared into y1 minus ky minus ky minus ky1, yep, minus ky, this ky1 please. This one is ky1 here, and this one is x minus h squared. I want it to be very clear, so that when you, in case you want to do it by yourself, so you have b squared into x1 minus h all squared plus x1h minus xx1 plus xh minus h squared. So at the end of the day, I have a squared to y1 to y1 y minus k into y minus k minus y1 minus k all squared equals to b squared into x1 minus h all squared plus x1 into h minus x minus h into h minus x. If you have gotten this one, we have finished everything. Everything is now easy. Now, let's look at this. We will have a squared into y1 minus k into y minus k, yeah, minus y1 minus k all squared is equal to b squared into x1 minus h squared plus x1 minus h into h minus x. Now, you can see what it's like. Now, let's divide through by a squared b squared. A squared b squared. Let's divide by a squared b squared. So what's that going to give us? It's going to give us y1 minus k into y minus k over b squared minus y1 minus k squared over b squared is equal to x1 minus h squared over a squared plus x minus h plus x1 minus h into h minus x over a squared. Now, let's add y1 minus k over b, y1 minus k squared over b squared to both sides and subtract x1 minus h into h minus x. Please, I want to do something for ease. This one will be minus x minus h. You can see this one just came the sign here, and then so for ease, so I just add this one to this one and this one to this one. So let's look. It's going to give us y1 k, y1 minus k into y minus k over b squared plus x1 k, x1 minus h into x minus h over a squared is equal to x1 minus h all squared over a squared plus y1 minus k all squared over b squared. And from our initial equation, we know that this one is equal to 1. So the tangent equation for this form is going to be y1 minus k into y minus k over b squared plus x1 minus h into x minus h over a squared is equal to 1. So let me write it very well, clearly. So as I've said before, it is just replacing one of the x's by x1 and one of the y's by y1. That's the equation of the tangents. So we have the equation of the tangents will be x1 minus h into x minus h over a squared plus y1 minus k into y minus k over b squared is equal to 1. That's the tangential equation for x1 minus h squared all squared over a squared plus y minus k, for x minus h squared over a squared plus y minus k squared over b squared equals to 1. So this is the tangential equation, the equation of the tangents.